What is geometry? Geometry is the branch of mathematics concerned with properties and relations of points, lines, surfaces, solids, and higher dimensional analogs. Now, that may sound like a lot, but we're going to break it down step by step, starting with the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared, but only for right triangles. After you add a squared and b squared, you get c squared, and then you must square root that to get c. You can do this by pressing the second button on your calculator. This allows you to access an entirely different menu. So you click on where the normal squared button would be, and then you plug in the c squared, clicking the equations key, which then gives you your answer. But what if you already know the hypotenuse, which is what c squared was, and then you just don't have a leg? Here's how you get that done. So personally, I square each side, so I square the side length and the hypotenuse, and then I subtract the side length, or the leg, by the hypotenuse, or whichever one's mathematics, I don't care. Here's an example for if you are looking for a hypotenuse. A is 6, and the side length for B is 4. Start by multiplying 6 by 6, which gives you 36. Then multiply 4 by 4, which gives you 16. Then add 36 by 16, which gives you 52. Then square root 52, which gives you 7.21. And for the leg, here's an example. 10 is your leg, and your hypotenuse is 65. Multiply 10 by 10, giving you 100. And 65 by 65 for the hypotenuse, which gives you 4,225. And then subtract 100 from 4,225, which gives you 4,125. Then square root the number, which gives you 64.22. Now, let's talk about finding volumes in cones, cylinders, and spheres. Starting with cones. Here's the equation. V equals pi times r to the second power times h divided by 3, which means volume equals pi times the radius squared times height divided by 3. So let's do an example. You have a radius of 4 and a height of 5, which gives you the equation of V equals pi times 4 to the second power times 5 divided by 3, which equals about 80.77. Okay, that's a lot. Let's break it down. You start by multiplying 4 by 4 because you are dealing with exponents. And in a math problem with an exponent, you always start with that before anything else. So that gives you 16. And then you multiply by 3.14, or pi. Then divide 5 by 3. And then you multiply what's left of 5 by 3 by 16, or whatever number is left after you multiply by pi, which then should give you about 83.77. Now for a cylinder, the equation is actually very similar to an equation for a cone, except V equals pi times r to the second power times h, so you don't divide it by 3. So let's break that down, but you already know everything from it. The only real change is that you don't divide it by 3 at the end there. So let's give an example. Your radius is 5, and so is your height. So here is the equation that you would now have. V equals pi, 5 to the power of 2 times 5 to the power of 2, times 5, which should equal about 392.69. Now, let's break it down. First, start by multiplying 5 by 5 because it's an exponent. And then, multiply it by pi. And then, you're going to multiply that number you got by 5 because that's the height, which in this case gives you 392 92.69. Now for spheres, the equation is confusing. V equals 4 divided by 3 times pi times r to the third power. Let's break it down. 4 divided by 3 times pi means that you're dividing pi by 4/3. That means. And then, in this case, because there's no height to a sphere, it's just purely the radius. There's no height in it. So then you just multiply the number by itself with the 3 meaning that you multiply by 3, so 3 times 3 times 3, or r times r times r. Now, let's give an example. Say your radius is 3. So, here's your equation. V equals 4 divided by 3 times pi times 3 to the power of 3, which should equal about 113.90. So start by multiplying pi by 4/3, then multiply r by itself 2 times, which should give you about 27, which then gives you about 113.09. And now we talk about something neat. Rotations, translations, reflections, and dilations. Rotations are when you rotate the shape by a set amount of degrees. Like here's an example, you have a triangle, and you rotate it 90 degrees counterclockwise. Now look at it. It's been rotated 90 degrees counterclockwise. And a translation is when you move an object on a grid. So say you have a square right here. You move it up 2 over 3. And now look, it's moved on the grid up 2 over 3. It's moved. Isn't that exciting? And now we talk about reflections. This is what happens when you draw a line and you put an object or a shape, or in this case a triangle, on one side, and then you reflect it over this line, which then gives you a reflection. And then we talk about dilations, which is when a shape shrinks or grows by a multiplicative factor. For example, you have a triangle with all the side lengths being 4, 4, 4. Then you dilate it by 0.5, which is basically just you're dividing it by 2. So the side lengths become 2, 2, and 2. Next, congruent figures. Congruent figures are when two shapes are the same, just in different spots, like these two octagons. But on the other side, there's similar shapes. Similar shapes are the same shape, just different sizes. But what if you want to know the side length of one of the bigger shapes? Simple. Guess and check. That's kind of it. But I guess I should explain. So if you're trying to find the side length in a bigger shape, you would want to do it by 1.5, 2, 3, etc. with bigger numbers defined for bigger shapes. And then if you're looking for the smaller one, you would want to do it by 0.9, 0.8, 0.5, and etc. and all those other nice numbers. Parallel lines are when two lines go the same direction and never intersect. And angle lines are formed when you slam a line right in a point where they both go, which is pretty easy to do. Now, this line creates a bunch of separate angles on there, all adding up to 360. Now, because there's a line through it, there is at least 2 points on each side where the angles are the exact same on both. Isn't that quite neat? And remember, this is actually really useful, because if you go into carpentry, you're going to be using the Pythagorean theorem all the time, so remember this.